Figure 1 below represents the successive positions of a flying wild goose during a total time 0.4 seconds. The time needed to move from one position to the consecutive position is 0.1 seconds. So we can see here in the figure the first position of the goose, so this is 0, no distance is covered. Now the second successive position after 0.1 seconds is B, which is 8 meters away from the initial position. The third successive position is C, which is 16 meters away from the initial position, D, E, and so on. So indicate the trajectory of the flying wild goose. The trajectory of the flying wild goose is a straight line. By trajectory, we mean the shape of the pathway. So this is a straight line because if we join the successive positions, it forms or they form a line. They are collinear. Now part 2, calculate the average speed of the goose as it flies from A to B, B to C, C to D, and D to E. So now, in order to calculate the average speed, we have to consider the total distance over the total time during or between these two positions. So I'll call it VAB. By VAB, I mean the average speed between A and B. This is equal to the distance covered during this time, which is AB. So this is equal to AB over delta T. Here the initial rule is D by delta T. So now I called it AB. It is equal to 8 meters. And the time separating the two positions is 0.1 second as mentioned in the given. So this will be 80 meters per second. Now VBC is equal to D during this interval of time or between these two positions. So it is BC divided by delta T. Same thing here. Now the point is that you have to show me your work and you have to show me that the distance BC is actually equal to 16 minus 8 in order to get this part, which is the distance covered during this time. So this is the distance left. Okay, so we can say here that it is 16 meters minus 8 meters over delta T, which is equal to 0.1 second, and then we will obtain the same value, which is 8 meters over 0.1. It is 80 meters per second. VCD and then VDE. You have to do them all, okay, in the same manner. So this will be now as for CD, it is actually here CD, not BC, and we will have to write 24 minus 16. So this is 24 minus 16. Again, we will get 80 meters per second. Similarly for DE, again it is DE over delta T. Now it happens that the same distance here covered during the same interval of time is the same. That's why we are obtaining equal values for the average speed. So now DE is equal to 32 minus 24. It's the distance between E and D. So this is 32 minus 24 meters 32 minus 24 meter. So again, we will obtain 80 meter per second. So what do you notice here? We notice that the average speed during any interval of time are all equal to each other. Now, did you use the type of motion of the goose during the 0.4 seconds, yani from A till E? Because all average speeds are equal to each other, so this is U R M motion. What do you mean by U R M? U is for uniform, and by uniform we mean constant speed. This is constant speed. Okay? Now by R we mean rectilinear, because the pathway is a straight line. So this goes back to the answer here, because it is a straight line. And M for motion. And M is for motion. So the justification here is that all the average speeds are the same. We have constant average speed. Alright? Alright. Now part 4, if the goose keeps moving in the same manner, this means at the same speed, determine the instantaneous speed of the goose at t equal 1 second. So now for part 4, okay, we say that V instantaneous is equal to V average, and the average speeds were calculated in the previous parts, which is 80 meter per second. When can we consider instantaneous speed equal to the average speed? This is only when the motion is U R M motion. Alright, only because this is U R M motion, V, and then V instantaneous equal V average. So this is true only for U R M. This is very important note here. So this is very important idea here. So because the speed is constant, the moving object covers equal distances during equal intervals of time, and thus now V average is the same and is equal to the instantaneous speed. So calculate the distance covered by the goose after 1 second from the initial instant of motion. Usually, whether URM or UARM, we have to refer to the instantaneous speed in order to measure the distance covered, because it depends if the object was moving fast or slow, then the distance is affected by the speed. But here, because in URM V average is equal to V instantaneous, we can calculate the distance by using the rule of V average. So we say that V average is equal to the distance covered over the time. So we're looking for the distance here. Okay, so now the distance covered is equal to V average times delta T. The average is 80 meters per second times the time here is 1 second. So seconds and seconds cancel, then the distance covered is 80 meters. And also very important note here, we calculate the average, the distance covered by referring or by using the average speed rule only in URM. We cannot do the same thing for UARM, and we will see this in the upcoming exercises. Okay, so this is a very important note, remark. All right, this is a remark here.